Hello. Hello, everyone. So this speech or talk presentation is about how to get as many cows on a 4S as possible, and using the GPU basically. The goal of this presentation is not really saying this is an awesome thing you can just download from the App Store or the Unity Asset Store and it'll be just usable. It's more like hopefully an inspiration so that you will be able to start thinking more about how can I use textures in the Vertex shader and how many strange things can I do with it. So looking at some other talks here at Unite, there's a lot of fancy graphics, and this is it doesn't look very fancy. It's all kind of prototype art. And but the good thing is it works on oldish devices. Originally, I developed this technique for having wind in grass and crops and so on for farming-related titles, and we wanted to get more animals on these farming-related titles, and we try to put the same technique into use for animals. So, because a lot of animals was one of the kind of pain points on this specific prototype, at least. We had high costs because of the individual draw calls. We paid a bunch of costs for the fancy animation systems with blending. We didn't use IK. Even if you don't use blending, you're paying some of those costs. And at least by default in Unity, you're using CPU skinning, and which is really powerful, really good. But if you want tons of animals, you might want to try to offload the CPU as much as possible. So yeah, if you're using CPU skinning, you probably will be CPU bound if you start having a very large amount of characters. So the goal here was to move as much as possible to the GPU. And another kind of side benefit is that the more stuff you put on the GPU, the more maybe you can be able to batch, meaning you can clump things together and lower the number of draw calls. So that's our beautiful example cow. A similar technique, the art style and the character types we were looking at we call them puppets. They're basically made of very few vertices, and I guess it started with Castleville and those types of games where it's more like one of those clowns you can pull, and their body parts are just one quad basically. So that's basically what this cow is made up of, 87 vertices, and some of them are like strips, and some of them are just like the head, for instance, is like one quad, and the ears are one quad each, and so on, and the jawbone might be one quad. So the way we tried storing these animations are not with bones and skeletons and skins and bone weights, and it's actually simpler in many ways, where we just stored vertex positions in textures. So there's a lot of things you can't do. You can't do blending very easily and some other things, but the good thing is everything can be done on the GPU, and it's ridiculously fast. Yes, moving on. Yeah, let's see it running first to get you guys not running away from here. I have this, oh no. What should I do? AV people. Okay, I just turned off mirroring. You can feel free to come up here and hit me if I did something wrong. So I have the stats thing here already just to show the number of. The important thing here is the number of batches. I don't know if it's probably not really that easy to read, but it says 2 because we have 1 for the quad and that's the ground. But it's basically a bunch of cows. This example actually is maybe 600. They all play individual animations. They each move independently, rather. And if I, just for fun, I'm going to turn off that quad underneath. Do you see that it says 1 batch? I don't know. Well, you have to trust me. So that's the demo that should make you a little bit excited and believe I'm not totally lying to you. And I'm also saying that this works fine on the 4S and so on. Some of these animations are really strutty, the walk, and some of them looks kind of silly. Oh, this guy's just sliding. It's maybe a bug in my prototype, but or maybe it's a. See, it's just comedy. It just write itself. You just look at, oh, this guy's looking back at me. This guy. What are you doing? Why is my ear messed up? Okay. Well, this was fun. Back to the presentation. I'm going to take away the mirror displays again and go back to this thing. I'll try. Are we seeing the right thing? Awesome. Okay, so that was what the final result was looking like. I was kind of thinking about, should I put the result at the end and just slowly lead up to it, or should I just get it pretty early so you guys get excited about what is this? Anyways, so the rest of the talk is going to talk about like what was going on in that example and what were the kind of goals to make this as feasible as possible. So the first problem or the first thing you would run into is how to use less space in textures. Like, luckily we had only 87 vertices, but if you have every frame in an animation taking up, uncompressed, it would take up a lot of space, or at least some space. So we're going to do something about that. Another question is, how do you get the 3D position into a color without having horrible resolution, and kind of go through what the shader is up to and what it will do. So the first colorful slide here is what the animation would look like as a texture without any compression or whatever. So each row here would represent a vertex, and each column would represent a time. So this would be a timeline from the beginning of the animation to the end of the animation. This is probably an idle animation. I imagine the purple-blue thing in the bottom is probably the tail wagging, or what do you call it, wiggling in the back. So this would be the kind of starting point. And don't worry too much about how the bad resolution of 8-bit per color will work. We'll talk about that later. So the first step on thinking about how we can kind of compress this information is, you see some of these rows, they barely change at all. So we don't need, let's say this is 100 frames or something. We don't need 100 frames to represent it. So the first kind of concept is to just downsample keys or animation, keyframes basically, or one animation curve. So a simple example would be you can apply the same logic to like a one-dimensional movement, just like an animation curve. So the question is basically, how much can we scale it down without losing too much of the quality? So in this case, maybe this is how much we can scale it down without the kind of aggressive move. The high frequency motions in the beginning is going to look bad. And this is what it would look like after doing that. You see some vertices doesn't have much animation at all, or it only has very low frequency animation, and they will be short rows, so to speak. And the ones that have a lot of stuff going on, or it has at least some high frequency information in part of the animation, they can't be squeezed down very much at all. But at least maybe we cut it to a third of the beginning, or maybe even a quarter, I don't know. The good thing is we can actually do better than that. As you see, like traditionally in animation compression, you can determine the time between every keyframe. Because of the way the shaders work, and we don't want to have search algorithms in the shaders, it will be harder to do that. But we can do something similar. We can divide the curve into equal time segments, and then we'll go into why it's important that it's equal time. But if we divide the curve into multiple segments, we can basically downsample each segment by itself. So the high frequency stuff will preserve the detail, and the low frequency stuff will just be more blurry, so to say. we will, to be really smart about this, we'll also try different number of segments. We can try with 2, 3, 4, 5, as many as we want. So in this case, I think it's 14. Yes. This also adds a requirement that we, for each curve here, we add some type of time information. How much did we squeeze time together? How much did we stretch time out? So it's similar to the concept of time warp in Maya. You have your animation curves. You have your animation, and you can have a separate curve where you speed up and slow down the animation. That's its own control, and that's basically the same concept except per vertex. At that point, after this nonsense, you get that much texture space usage, so it cut it down by about half again, in general at least. And this is what the time information would look like. And this is going to be maybe a little bit confusing to wrap your head around, but this is the reason why the segments have to be equal time, because when we go through the animation between like 0 and 1, we're going to basically scan each of those rows or scan lines on the right, and we have to do that with basically an equal, we're going to move through that in a smooth pace, and then that time information is going to adjust how much ahead or behind in time we look at the keyframes to the left. Just so you know, it's very, very fancy. So now this cow has to be made up by the vertices, right? So now each vertex have to know the location of and the length of each of these strips. So each vertex has to know where this animation, so to speak, starts and how long each strip is. It has to know what the duration of the animation is, and that's actually going to be shared between all the vertex in one animation. And it needs to know the start time of the animation, when the animation started in real time. So that's like seconds since the boot or something like that. Okay, that was it about the vertex attributes, what's kind of in the text, how the animations are compressed. This is the next piece that's, something. So each of those texels you saw each of the pixels in the texture is representing a 3D position. Red, green, blue is just translated to X, Y, Z. And in a normal texture, you have 8 bits per channel, which is pretty bad. You get just 256 steps where each vertex can be, and that looks pretty bad. You cannot have much resolution at all. It would be nice to use something with some texture, color modes, format modes are kind of made to work better, but they're not available on many devices, at least the ones we were looking at, the low-end ones. So I kind of tried this, and it kind of worked, where you have a color cube, the RGB, and then the alpha channel is a scale. So it can scale up and down that cube. The good thing with that approach is that you can basically do a little search. You can try to quantize this position into this cube. You can try all the different scale values that is available to you. When you do that, those colors that we saw earlier would be very noisy, because some of the scale, the magnitude would be shifted off to the alpha channel, and it would be much more noisy. So I took that away from the slides earlier. Yes. So what the shader does in this case is for each vertex. So each vertex is animated independently of any other vertex, which is strange, but it kind of makes sense. That's also why it's so parallel, right? Where that's the power of the GPUs also, that you can do that. So for each vertex, you figure out what the current time is. Exactly, that's the uniform that gets fed every frame. So you know what the time where this animation started, you know what the current time is, and you have some information in the vertex on how long the animation is. So you can get the normalized time, like between 0 and 1. So you have a time between 0 and 1, you apply this little time warp thing, basically the black and white part of the texture, to find where your keyframe is or where you should interpolate. You get that position, that was the colorful part of the texture earlier, and you do this alpha is a scale thing, and you get a position out, and just for good measures, you saw the cows were walking left and right. That's done in the shader also, just flipping based on something that's in the Vertex attributes also. That's not it. Then we want the UV animation. We want the flipbooks, basically. That we had the earlier part working pretty much earlier than when I got this working. But what we want is blinking. We want chewing. We want certain things to be done with flipbooks, especially when we have these puppets. There's a lot of movements that can't be done easily with animation. Like you see the cow that was looking back at us. That's a flipbook. That's like switching that card from the normal head to another head that's looking at the camera, basically. And that's one of the examples, the different eyes that are available for animators to choose from, basically. And this is what that would look like. Each row here is the same as for positions, but it's like UV sets or UV positions. So this is very similar to the animation we talked about just now. It's a little bit different because the UVs can't like slide between values, so they have to jump between values. But that's basically the difference between interpolating when you're reading sampling the texture basically from linear mode to just point sample. And it's also important that they jump at the same time, so you don't have half of the eye switching in UV before the other parts and so on. But luckily that it all works basically the same way as the earlier algorithms, except you have the error you're measuring when you try to downsample and upsample has to be in time, how off in time you are, and not how off in space you are, if that makes sense. And using the same compression thing, it basically goes away, which is a good thing. And so UVs are, most of the time, they're not animated, at least not in our examples. It's just the head, it's basically the head and the eyes in this example. You see the 2 sets of 4, basically 2 quads are flipping UVs. Another interesting pro with this is that the UVs are often the same between animations, and I'll show you soon that we'll atlas all these animations together, and all the same UV sets are just going to be deduplicated in the atlas anyways. So it takes up very little space. It's just the texture samples you pay for, but it does get us the animation of the UVs that we wanted. And again, even more vertex attributes is needed for this to work. Yeah, so this is a beautiful example of the final atlas. It's actually 2 textures. The bottom one is all of the different kind of time bending little strips of texels, and the other one is the positions moving. And actually, if you look at the first 8-10 rows, that's probably the UV sets or the UV data, and the rest is movement and positions. Can look at that forever. It's like hypnotic. Okay, that's not it either for this example to work. We also have instancing, as we say it, because we wanted to get this one draw call. Means that all of these cows are drawn, obviously, as one vertex buffer, one mesh. And normally when you do this instancing trick is that each vertex knows what instance or what cow they belong to, and they look into a uniform array. The downside of uniform arrays in Unity, unless something changed recently, is that there's a limit to 99, so you couldn't have more than 99 cows. And there's also some cost of updating these things. So just because I was excited about reading textures from the Vertex shader, this is also done with a texture where you have one basically a dynamically created texture that is read by the Vertex shader to position these cows. So each pixel here is just the XY coordinate, and red and green is X, and blue and alpha is the Y, or the C to be specific. Yeah, and now every vertex attribute also needs an instance to know where in this texture to get their position. One of the problems we got, I got when I started getting it to work like on the Mac or on the PC, and then I realized once we moved to the iPhone that at least the older devices are not, the newer are maybe not the same. When you sample the texture, you try to, let's say, you try to look between two samples or two texels, the resolution of that interpolation may not be better than the color mode or the basically 8 bits. So if you have like amplified and you have positions that you read from this, you actually get very visible jumps and you don't get the smooth movements you need. So on the low end devices, I just needed to do both. I just need to take both samples and do the interpolation in the shader, which felt bad, but it's life, I guess. I'm not showing it on the 4S because I don't want to bug the AV people about that. Okay, so there are obviously a bunch of limitations for this technique. The most crucial one is probably that the vertex shader has to be able to sample textures, which is not true for some older Android devices. Every iPhone after 4S can do it, and most Android devices. It's one of those things that the Android devices that don't do it are basically cheating, I would say, because it's in the standard that the vertex shader can sample, but there's also kind of a loophole where they can tell you how many textures are you allowed to sample, and some devices just return 0. So yeah, they were like, well, we're technically compliant here. Yeah, so that's why you need a lot of devices, right? But yeah, the bad thing is that a lot of those cheap devices don't do it, and they have a pretty big market share in poorer countries. Yeah, another thing that's kind of a limitation is that this 8-bit per channel plus a scale thing, it works well enough if you have really low poly characters or models, such as these ones, where the space between them between the points are big enough so that small kind of changes aren't that visible. If you would have actually fancy characters with like 4,000 verts with like less than a centimeter between the verts, it may not be good enough for that at all. Another limitation is that every time one of these animals are changing an animation, this is why originally it was meant for grass and stuff that just sat in its place, didn't do too much. It was waving, everyone was happy. The problem here is that if you want to change an animation, you basically have to rebake you have to re-upload the vertex attributes, the vertex data, which isn't that bad, but it's, yeah. Okay, so yeah, I did the perf tests before I added the UV flipbooks and instancing, and I haven't been motivated enough to redo the tests. But so on the 4S, with this technique, we could draw over 6,000 cows, which is exciting. Doesn't mean that it will go into a real project that ships anytime soon anyways, but those were the results. And yeah, congratulations for surviving the talk. I have some shader code below that we can look at, but we could just move into some Q&As if you have any. We have like a few minutes left for that. Questions? We have questions over there. Okay, yeah, we can. It's not very long. I just pulled out and honestly, nothing here is very fancy. It's just avoiding, every line is a off by 1 mistake, a honeypot or whatever. So it's basically like this. You get the local time, which is the 0 to 1 time, and yes, we unpack those things because they're stored in a special way. We call this fancy sample function that I'll go to later, and we get the sample time. We do the bend time, which is moving it back and forth, and then we do those fancy samples to get the position, and then we get the UVs from another thing. This is a helper function to get 2 numbers, like pack 2 numbers into one float. We didn't talk about it, but that's what we had. I basically ran out of vertex attributes, so I had to start doing stupid stuff. and then how to get 16-bit values, UVs out of a color. Oh yeah, here's the fancy sample thing where it's basically moving into the center of the texel, scaling the normalized time, basically taking the x-coordinate of the UV coordinate, moving it along the right amount based on the current time and based on the size of the length of this animation. And then, scaling it to the UV space and then doing the lookup. And the little bend the time there is basically just adding and removing, but it has to do some scaling to go from 8-bit to whatever. And yeah, that is the end. So any questions that aren't just, show me more stuff. Was there anything specific you wanted to ask about that? Yes, one question here.
Just a quick question.
Yeah.
How are you generating the texture in the first place?
How I'm generating the texture in the first place? Yeah, it's a C# program, basically taking, so I had a TD basically write an exporter. Like originally I just ran Unity and just took the vertices and printed out, but then I'll get someone to help me write my exporter, and I basically have a program that compresses them into this, to the Vertex attributes in one file and the textures in another file. So yeah, this is just the tip of the iceberg, I'm afraid. More questions? Yes?
What was the point of doing the compression of the information? Like you basically had rows of texts that then became shorter.
Yep.
But it looked like it was still in the same size texture.
No, so if you look at the atlas, the final atlas was the noisy thing. So they are all packed together. There's no reason for them. The only thing is the vertex attribute has to point where it starts and how long it is. So it was trivial to pack them together. It's just a one-dimensional thing. You just stack them on top of each other. More questions? Yes? I'm going to guess like 256 by 160 maybe. And it's not compressed further, obviously. Yes? Probably not. Not anytime soon. I mean, it was a prototype. I'm not sure if exactly what's going to happen with the game that the prototype was made for. We'll probably try to ship a game using this. And yeah, we're like a for-profit company that just, so this, that, yeah, again.
I might have missed it, but how did you offset the time? Like, how did you select an animation for each count? Is that like in the same texture that you positioned it?
I'm not sure if I understood the question.
So, like, all the counts, they're not doing the same animation?
Yes. Yep. Yes, so each vertex has a UV, a pointer, into this texture. So each vertex can point at a different animation, a separate animation. So this atlas here, I call it an atlas, even though I don't know what it looks like, has all the animations for all the vertices. I mean, now it's just 2 cows, and the positions are also deduped. So even though they start out as 2 cows, they have the same animation data, so it got deduplicated and mixed. They did not have the same UV data, so that's separate. But so yeah, it's 52 animations, but maybe it's actually 26. I'm not even sure. Yes.
Wasn't quite clear on whether this was mapping.
Oh, sorry. Yes.
Positions or a change of position for each vertex.
I tried both. This is, so for each model, or actually for each animation. So in this case, the interesting thing is the positions are not in the vertex attributes anymore at all. It's just basically a center position. I tried doing having the actual position and then add an offset. But it turns out some animations we tried on, buildings specifically, we had like a building with a water wheel, I don't know what it's called, and, or actually no, a windmill, where you actually get worse resolution because you have a larger offset if you just do the center from something that's spinning, you get the smaller kind of distance, so to speak. And if you actually do the offset from the original position or from the bind pose, you can get larger scale needed, if that makes any sense. So yeah, it's the full position in the texture at this point, or an offset from a center position of that animation. Yes, man in the hat.
I was wondering if you tried storing like shorter, like more compressed tracks for vertices into like different bit levels to get like a smaller overall texture.
Sorry, I didn't get it.
So like you have like different bit levels for your texture.
I have,
So you have like the smaller versions that you can store.
oh, MIP map levels.
Yeah. So
Yes.
if you have a track that's like shorter than 50%, you can potentially store that in like bit 1 or whatever. Is that something you would look at?
I'm not using MIP maps. And I'm honestly not sure if MIP maps are even easy to access from the Vertex shader. It doesn't seem like a normal use case. Since it's not scaled with distance like a texture for a pixel shader often is. Yeah, I don't remember all the specifics, but I don't think MIP maps I definitely didn't use MIP maps for this data. Well, thanks for coming, everyone.